4:15 p.m.
Okay, when you're factoring, of course, you're trying to find things that multiply. And most of the time, you're going to be trying to undistribute. Okay, so you want to get something in parentheses and something not in parentheses. Okay, so think about this as undistributing, where you're going to have something on the outside, parentheses, and then a bunch of stuff on the inside of parentheses. Okay? So all of these first ones are going to look like this. You got stuff out here, and you got stuff inside of parentheses. So, greatest common factors. So the greatest common factor are the largest set of multipliers each term have in common. Okay, each term must have it in common in order for you to be able to, quote unquote, factor it out. So there's lots of ways to do this. There is the elementary way. We can expand. So 3x to the fourth is 3 times x times x times x. And 9x squared is 3 times 3 times x times x. Okay? No, you don't have to do this every way, but this is a very elementary way of looking at it. Because the terms, the things that they have in common, are what you're able to factor out. Okay? Common multipliers. So both of these terms have a multiplier of 3 in common. So we write that down. This is what they have in common. And they both have, at most, 2 x's. So each of these terms have a 3 as a common multiplier and 2 x's as a common multiplier. So once you run out of things that every term has in common, that's when you put your parenthesis. And you write down what's left. So we no longer have a 3, we no longer have 2 x's, so our first term just has x squared left over. And then we have the plus, and our last term has just a 3 left over. And that is the factorization of this algebraic thing right here.
So that's all we have to put. So this is confusing.
That's all you have to put. Something on the outside, everything that each term has in common, and then all the leftovers. Okay? Now, if everything is in common and you have no leftovers, you have to put a 1.
Outside?
Inside. You have to put a 1 inside if everything is taken out.
How's that confusing? You just put a 1. Stupid.
We'll see what that happens in here. We'll see. So, here's another example. 16 m to the fourth n.
Alright, it's just 1m, right? Because there's only 1m over there.
So let's see, yes. This one has 1m, this one's got 2, this one's got 4.
So just 1m and 1n.
So it each has 1m in common.
And let's go 4.
And it's got an n in common.
4m, n.
And a 4.
And it's outside, right?
Okay, yes, outside because each term has a common multiplier of 4. This is 4 times 4, this is 4 times 2, this is 4 times 1. So they all have a common multiplier of 4, and they all have 1m and 1n.
Alright, so what do you do with the parentheses then?
So now that we have parentheses, we see what's left over.
You still write the minuses and pluses.
Yep, you still write the minuses and the pluses, so one of our 4's is gone, so we still have a 4 left.
4 and 3.
And we have 3 m's. So we had 4 m's, we put 1 out here, so we got 3 m's. We took it out there. Minus. So this 4 is now gone.
So we got a 2.
2.
2 and 1m.
1m and
2 n's.
1n.
Oh, 1n. You're right.
Because you had 1 and 1.
My bad, brother.
Plus, the 4 is gone.
Plus 1. You don't have to write 1?
We don't have to write 1 as long as there is a number,
a
number. 2, just an n squared.
I didn't get any of that.
Hey,
Right? Had there not been an n squared, there would be a 1. Okay? So we're looking for things they have in common, and then you divide. So we divide. 16 divided by 4 is 4. M to the fourth divided by m is m cubed, and so on and so forth. Okay, let's see what's next. Oh, factoring by grouping. Okay, another way that you can factor, especially if it has 4 terms. Okay, this might be the way that you want to try to factor this. So when we factor by grouping, sure enough, all we have to do is group them.
Right, we got 0 x's.
And we group them with parentheses. So group the first two things and group the second two things. Now the question is, what do each of these two terms have in common?
They got 2 x's, brother.
They have x squared in common, which means they have what left over?
An x and a 2.
An x and a plus and a 2.
Why are you getting all sideways on that, right?
I don't know. Plus, what do 4x and 8 have in common?
4.
They both have a 4 in common. So what is left over?
X plus 4. X plus 2.
And x plus 2.
2. I'm 17.
So now the question becomes, look at this. What does this one term and this one term have in common?
X plus 2, brother.
They both have an x plus 2 in common.
Why is that going in for x squared plus 4? That piece over.
So x plus 2 is in parentheses already. So when you factor it out, it needs to stay in parentheses.
But if they're both parentheses, does it mean that?
That means it stays in parentheses.
Oh, okay.
Now, what is left over?
X squared plus 4.
An x squared and a plus 4.
They just finesse the parentheses. You gonna factor that too?
Nope. Well, potentially, but not right now. So, x squared plus 4 is not a factorable quadratic, so this is completely factored. Okay, sometimes, yes, you do have to check and say, ooh, can I factor this little term, this x squared thing more? Maybe yes, maybe no. In this case, no. So this is your factorization. Okay? So, most of the time, when you're factoring by grouping, this is what you're trying to get. Something parentheses here and the same parentheses there. So these two are in common, so we factor out this purple thing as 1, just like we factored out an x squared in common here and a 4 in common here. Both of these have an x plus 2 as a common multiplier. Okay, so factoring by grouping. Kind of weird, actually very weird, but we'll be okay. So you always group the first two things and the second two things.
Alright, can you, never mind.
So 5x4 plus 2x3 has an x3 in common, which leaves us with 5x and a 2. Yes, he is. Now, what do negative 10 and negative 4 have in common?
Let's go with a 2.
A negative 2. Now, if both of these terms are minuses, they have a minus in common. Okay? Now, when we factor this, what's left over? Negative 10 divided by negative 2 is 5x. Oops. Now that's going to be on the recording. Anywho. And negative 4 divided by negative 2 is positive 2. Okay? So if both of these terms are minuses, you have a minus in common, and then this becomes a plus. Because when we would distribute, this is where you get your negative 10x. This is where you get your
5x plus 2.
Negative 4. So, what's the same?
5x plus 2.
Holy cow. 5x plus 2. Isn't that pretty obvious when I do it in color?
He's going sideways again.
Stop it. And what's left over?
X cubed
minus 2.
Okay, good to know.
Okay? So, that is your
Is that club 9 right there, brother?
about 6.5.
Oh, like, cross, like, is that club 9?
It's more like a sheep. Bah.
Because you can see it.
Bah. Anyway. Factoring by grouping. You always put the first two, you always put the second two. Okay? One more example.
Yes.
Group here. Group there. 4x cubed minus 8x squared have a 4 and an x squared in common, leaving us with an x minus 2. 8 divided by 4 is 2. X squareds are all out. 7 and 14 have a plus 7 in common. Okay, when they're opposites, they have a plus, leaving us with an x minus 2. So this needs to have an x minus 2 in common and 4x squared plus 7. Oops, I didn't change colors. It would be okay.
For number 1, you get 3 and
Okay.
parentheses.
So anytime you're factoring by grouping, you want to group the first two things and the second two things and see what they have in common, and then common factor that. Bam.
Does it record your audio?
So there's some factoring by grouping. Yes, you're on it. My mic's right there.
Oh, so it's going to hear me being goofy. Oh my
Probably.
God. I'm going to be YouTube famous, Mom.
So quadratic factoring. Okay, these will be like an ax squared plus bx plus c's. Quadratic factoring.
What we're going to see, this is going to be the sheep.
2 or 3 terms. Let me on there. The sheep will be on there. Okay, so they factor to 2 binomials. An x in parentheses and an x in parentheses. Okay, so the key is what numbers multiply and add at the same time. So here's some very simple quadratic factors. This is how I've taught my kids for years. Make an x. What numbers multiply to give you 12 and add to give 7. And that is, of course, 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So your factors are x plus 3 and x plus 4. Okay? So, very easy, I think, with normal quadratics. What numbers multiply to give you negative 32? Always the last number on top. And add to give negative 4. So those are 8 and 4. So 8 times 4 is 32, but one of them has to be negative. So if the factor on the bottom is negative, then your larger thing is negative.
We're live!
So our factors become x minus 8 and x plus 4. Okay, pretty stinking straightforward when they're like this, and most of them are like that. So here we're again, what numbers multiply to give you 45 and add to give negative 14. Negative 9 and negative 5. Okay, that's the only way to multiply to get a positive and add to get a negative is if they are both negative. So x minus 9 and x minus 5 are your factors. Okay, so pretty easy with a standard quadratic. Okay, so fairly straightforward with a coefficient of 1. But what if we have a coefficient larger than 1? So here's how we do. We still need to multiply. But in this case, you don't just multiply the last number, you multiply the first. Okay, some people call this the AC method because this is your A value and that's your C value. You multiply them together, you get the top. So we're still looking for numbers that multiply to give you now 6 and add to give 7. So with the leading coefficient, it's not just the last number, it's a product of the first and the last number. So here we have 6 and 1. Now, because we multiplied by 2 to get in, we have to divide by 2 to get out. This is the way it is. So, because we multiplied 2 times 3 on top, we have to divide by 2 to get out. So, does 2 divide 6? Yes, it does. So this gives us our nice linear factor of x plus 3. Does 2 divide 1? No, it doesn't. So this gives us our coefficient factor, 2x plus 1. Okay, so we can always double check. X times 2x, sure, 2x squared. 6x plus 1x is 7, and there's your 3. So you can always double check to make sure you got your factors right by multiplying it back out.
So you wouldn't put a 0.5?
No 0.5s, only whole numbers when it comes to factoring. So this one, we multiply the AC. So 3 times negative 8 is negative 24, and numbers that add to give negative 2. Okay, these are going to be negative 6 and positive 4. Okay, but because we multiplied by 3, we have to divide by 3. And this works with all leading coefficients that are factorable. Does 3 divide negative 6?
Yes.
Sure, so that's an x minus 2 factor. Does 3 divide 4? No, so that's your coefficient factor. 3x plus 4. Always the bottom, what you're dividing by is the coefficient, and the number is your number over there. Okay? This is how you can factor any leading coefficients. So, there are also some special quadratic factoring. These are called difference of squares, and you factor them by square rooting. Okay, so we factor by square rooting. That's how you can tell that you have a special one. Each of these numbers will be perfect squares. Okay? So, what's the square root of 1? Well, just 1. The square root of 9 is 3. So one of your factors is x minus 3. The other factor is x plus 3. So when you have special quadratic factors, you always have a minus as one factor and a plus as the other. Okay? So square rooting. The square root of 4 is 2. The square root of 25 is 5. So one factor is 2x minus 5. The other factor is 2x plus 5. Okay, you factor these special ones by square rooting. So our last one, square root them both. Square root of 81 is 9. Square root of 16 is 4. But because there's a y squared, we need to have a y on our second term as well. So 9x minus 4 and 9x plus 4y. Okay, these are all difference of squares, so you have to square root them. Plus and a minus on each of your factors. Okay. Now these ones are sums. So you'll notice what numbers multiply to give you 25 and add to give 10 are both 5. So rather than writing x plus 5 and x plus 5, traditionally you see this as x plus 5 squared. Okay? So anytime you have two of the same factors, you write it as one factor squared.
Still shutting the hell up time, everybody.
Okay, so there are plenty of examples of factoring, everything from greatest common factor to factoring by grouping to amazing quadratics. Thanks for watching. Happy day.